Welcome back, folks. So now we know how exponential growth works. We saw a situation where, again, we started off with two bunnies on a farm, and every month they have two bunnies, but also their babies have two bunnies apiece, and it just doubles every month. So what I want to do is compare that to situations like these. Okay, and the question that we actually care about is which of the below situations, so that's case 2, 3, 4 here, will have the most bunnies after 1 year. Okay, so I'm going to just kind of summarize this, and I'm going to create 3 different tables side by side, and we'll get into it. Alrighty, welcome back. So I've written out scenarios just so I can do it side by side with the tables. Excuse me. So we have the month, and we have the number of bunnies here. So we'll just go through them one at a time, and what you should do is obviously you should pause them and try to figure this out on your own first. So again, in here, I'm actually not, just to get you started, I'm actually not going to fill out the table all the way through. And I'm also not going to worry about creating an equation, although you're welcome to do that. Okay, so I'm actually just going to create the table from 0 out to 5 months for each one. 2, 3, 4, 5. And then we will actually be able to answer the question, again, the question being, which of these situations will result in the most bunnies after 1 year. We actually don't need to create the table out all the way to 12. And so what I would recommend you do is pause the video, draw your pictures, fill out this table out from 0 months to 5. And again, it goes 0, 2, and 2. And just see if you can answer the question. Alrighty? Alright, I'm going to assume that you have tried that now, so let's try to work this out together. At this point, you'll just check your work with mine. Okay, so in the first situation, or I guess case 2 rather, we start off with 10 bunnies. So I'm going to do a quick little picture here. Again, I'm just going to draw circles here because there's a lot of bunnies already. We have 10 bunnies. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, I think I kind of messed it up. Let's try that one more time. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Again, each pair has 2 babies. So this pair, 1, 2. This pair, 1, 2. This pair, 1, 2. This pair, 2. This pair, 2. So you can count them up. We should actually have 20. Now, this scenario is actually very similar to what we just started with in the last video, right? There are 8, again, each pair of parents is 2. And if they had 2 babies, then the number of parents and babies is always going to be equal, meaning that you're just doubling the total. So you'll have 10, 20, 40, 80, 160, and then 320. Okay, this is more than the previous case where we just doubled every month, but we only started with 2 because, of course, we started with more to start with, so we kind of got a head start. Okay, now let's compare that one with case 3 and 4. Now, by the way, in the original question, the question here being which bunny or which scenario will result in the most bunnies at the end of a year, we hopefully saw that it can't possibly be this one. Why? Well, again, case 3 and 4, they start off with the same amount, but obviously this one grows faster, right? They reproduce faster, so of course this is going to beat out this one. So the question really is, how do I compare case 4 versus case 2? Because this one grows slower, but it starts off with more. Okay, so that doesn't prevent us though from still drawing this out and seeing, our growth patterns, because I definitely want us to check this out. You might think, and I saw plenty of people doing this in class, is that our growth rate is, okay, well, each pair has 4, so it goes times 4, times 4, times 4, which would mean that it has 8, and then 16, and then 32, and so on. Well, let's just check. I'm going to draw a picture here. So again, my students' guesses was 8 and 16. Great. We start with 2 parents, 1, 2. How many babies do they have? Yes, they have only 4 babies. So they have 1, 2, 3, 4, which means that you don't have 8 after 1 month. You have only 6. So again, you can't just look at that number as your multiplier. You have to actually draw it out to see what's happening. We'll try one more time just to see what happens here. But although you might notice something already, 1, 2, 3, 4, 5, 6 parents now. Okay, this was a little bit awkward, but I'll just draw the number here. This pair is going to have 4. This pair is going to have 4. And this pair is going to have 4. So we have 6 parents plus the 12 babies, meaning that we should end up with, I believe, 18. And so our pattern here, well, sorry, I didn't draw it over here, times 2, times 2. It looks like it's from 2 to 6 is times 3. 6 to 18 is going to be times 3 again. And so that's our pattern, is times 3, or our multiplier rather. So that's going to be 54. I believe this is 162, and then 486. Okay, so actually we can already see that it looks like case 3 beats out case 2 already, right? Because yes, it started off with less, but it's multiplying and it's already growing faster and faster, and plus it's already beaten it out at 5 months. Okay, so let's check out case 4, excuse me, and we'll draw a picture. So 1, 2 parents, and they have 6 babies, so they'll have, well, 6 babies. So in total, we're gonna have 8. We'll have again 8 parents, 1, 2, 3, 4, 5, 6, 7, 8. They're gonna have 6, 6, 6, and 6. So that's how many babies? I think that's 24. Plus the 8 parents, so that's going to be, I think, a total of 32. And so you can see our pattern here. That's going to be times 4 to get from 2 to 8, and 8 times 4 gets us to 32 as well. So our pattern here is going to be times 4, or our multiplier rather. Okay, so we have 32 times 4, which is going to be, I believe, 148. Oh boy. Okay, and then this is gonna be 5. Let's see, 148 times 4. So let's see, that'd be 600 times. Sorry, 150 times 5 times 4 is 600. But I'm gonna take away 2 from each of those. So I'm gonna be at 192. Sorry, 592. Excuse me. And then that times 4 is gonna be. Let's see. I believe that's gonna be 2. Okay, this one I can't do for some reason. It's very early today. Let's see, I got 8. We have 6, and then 3. 23, 68. I believe this doesn't quite feel right. Hang on, give me a second. Sorry, but I did something wrong. It was this part. I apologize. It's 128. There we go. Oops. 128. Then we get to 512. And then we get to 2048. Great. Okay. So as we can see, again, as expected, case 4 grows way faster than case 3. And what's really interesting is that, like, with a slope of just, 3 to 4, it doesn't really seem like that much. But when our multiplier goes from times 3 to times 4, it's actually a lot faster. So just change that one little bit here. Even though we started with the same amount, again, we're like almost 5 times, or I guess 4 times as populated as we were in case 3. Okay. So quite clearly we can see then, again, this one is only going to keep growing faster than the other 2. And so this one for sure will have the most bunnies after 1 year. My challenge to you then is to create the equation of this to then figure out how many bunnies after 1 year. And I'm not going to answer that question. I'm not going to answer that question for you, excuse me. Last thing I want to do is I just want to graph this scenario, and also just to see, again, what the graph of this kind of thing looks like. So we're just going to do case 2 here. Oops. Okay. So I'm just going to graph it from 0 to 5 months. Sorry, from 0 to 5 months. So I'll try to get this as accurate as possible. So we do want to make this kind of helpful. So I'm just going to count backwards. So let's see, this will be, I guess it makes sense. We'll go by 20s, I guess. So let's go, we'll do 320. Then let's see, every 5 would be 100. So let's see. Wait, maybe it's easier to do this. 300. All right. So scale your axes appropriately, and I'll be right back. Alrighty. So again, I'm graphing case 2 right here. So in month 0, that's our y-intercept, our starting point. I'm going to graph this in red here. We have 0, 10. So I'm going to plop this right here, right there. That's going to be 0, 10. Okay. Our next point is at 10, 20. Or sorry, 1, 20. So that's going to be right here to here. And so it doesn't really grow that much, right? Okay. So you might, again, if this is a linear function, at this point, it just looks like this kind of flat line. And I'll draw that in just to compare, although we know it's not linear because we've talked about that. This would be if it was constant adding every month, but it is not. So that's, actually, I should probably draw it in with a different color. Let's use green here. So again, this is linear, which is just a straight line. Okay, our next one, again, that's at 2, 40, so that would be right here. So we can see the jump from 0 to 1 and then 1 to 2 is different, right? Again, it's getting bigger. It's actually twice as large as what it was, right? So again, we can see our height or our y values went from here to here, and then went from there to there. Again, they're doubling each time, right? Each y value is doubling, doubling, doubling. We'll go to the next one. At 3, it's at 80. So that's going to be right here. Again, each of my ticks right here is 20 bunnies. I guess I didn't label my axes. I apologize. You should label your axes. So let's put number of bunnies. And then months. Already continuing on. So I got 4 now at 160. So that's a much bigger jump than it has been. That's going to go right here. And then once again, 5 months. Again, that jump doubles again. And that's going to be up at here, 320, way up there. Okay, so we can quite clearly see that our straight line is not going to fit through these points. And what's the shape that we're going to need is this kind of curved line. And it's going to look something like this. Oops. Okay. Now you might notice, like, I drew a little bit going off to the left-hand side, and we're going to talk about that more. It'll make more sense when we talk more about exponents and their properties of exponents, but I do want to point out that this is not a parabola. It kind of has that shape, or at least if you look at the left half of it, this highlighted bit, or sorry, the right half of it, it does kind of look like a parabola. It is actually not. So I want to be careful of that. So we're not going to say the shape of it is a parabola or half parabola or anything like that. It's its own shape. This is the shape of an exponential function. That's really all it is. It's its own shape. Alrighty, so again, after these last 2 videos, you should hopefully understand, hey, in a table, how do I identify exponential growth? How can I create the equation to represent exponential growth? And what does the graph of exponential growth look like? So thanks for watching. Hopefully this helped, and I'll see you later.